Hello, and welcome to another stream with me, Ginger Bill. It's only been a few hours, but you probably not missed me anyway, because this is the internet. So you can always watch me at any time you want, as creepy as that sounds. So I'm just posting this link now to all of the social medias to say I'm back again. Alright, of course. Back on the grindstone of Twitch. That's not really hard work now, is it? Of Right, so back to that then, are we? So we can probably carry on with whatever we want to do. So, hopefully people are doing all right. I'll wait for people to come slightly, because this is, again, another impromptu stream again. I'll probably try and do another one tomorrow or something, maybe during the day. I don't know. Things happen. So, what are those? This is the cheapest diet lemonade you could get. It's great. Cheap. Right, so for people who don't know or didn't watch the previous stream or just want to catch up of what this is, so for Odin, we are working on a new backend system as an alternative to LLVM. And what we're using is something called the Tilde Backend, which was developed by Negate for his C compiler, Quick, as he calls it, or Quick, as I keep joking. And it's a very good little thing. It's a very quick C compiler, obviously, and the backend is the Tilde backend he's been using, or tiny backend, or whatever, or tuberculosis. It doesn't really matter, whatever you call it. I'm going to consume it, so maybe it's consumption. Don't know. But the agreement here, and it's an SSA-based intermediate representation, which then can be lowered down into machine code of whatever target platform we need. So it is a very similar to like what the same level as like LLVM is, but because it's based on like the work of like Cliff Click and many other very good clever people in there, obviously, it all works. So this is what we've been doing, and we're just slowly working through all of the stuff. If it makes any sense, and trying to improve it as we come. So again, hello, welcome to the stream. This is again another impromptu stream today. I'm not really got a schedule of anything of this kind. It's just what I'm doing today. Yeah, shall we carry on with what we were doing? So carry on with this. Again, if you've got any questions at any time during the stream, just please answer them in the chat, and I'll try and read them out live on air. Right. So one thing I tried to do just literally just before the stream started was trying to get the debug system or the debug type stuff working. So one thing I need to do is go from the debug types to, from the types to the debug types. So I need a pointer map type to a debug type. Like that, until the backend module create map init. Now that could be map destroy, as they say. So then what I can do here, I'm just going to in a minute just try and make it all go in mutex, not mutex, there's no mutex, but map get type tb debug type found. If it has been found, then we can, if found, return found. And we can then just set it as well. Result, and then return the result. Okay, so this is just a little bit of optimization stuff. And then we can add a kind of, just say a blocking map or something might be useful. Blocking mutex debug type mutex, like so. This isn't initialized because 0 by default. So this is one of those things where it's probably not blocking. We want recursive, actually thinking about it. Recursive. Mutex block. In fact, defer mutex unlock. like so. Yeah, there's no other further quality options. Apologize. Someone complained that I didn't have enough and I was 1080p wasn't enough, so I went 4K. And now it's probably too much. So, good luck with the stream quality. Yeah. So it's only 6 megabits. That's wonderful, because clearly there's not much encoding going on when it's text in my face. And I'm not moving around. Even if I moved around a lot, this is like a very small box, which is like tiny. It's not even 720p height, but whatever. We're doing the thing. "4K picture in picture, you need to be like this. It's just me. Hello." Oh yeah. We're back. Back to the text. So we can then transition between the stuff. But yeah. So this is now the absolutely dreadful thing. That should be a double pointer. Okay, dokes. So now, is it crashing because I've got something gone wrong here? Is that debug map got initialized correctly, right? What if I do this? Yeah, there's a bug elsewhere. Let's find out where the bug I introduced. To do. Yeah, of course it is. But where did I introduce this? Oh yeah, here. It's the 128-bit integers. I haven't supported them yet. So let's just say remember, because Negate has cocked up the 128-bit integer stuff at the moment, I am working just pretending 128-bit integers are actually 64 bits. And only 64 bits. Did you ask for the rights? Ah, no, it's a problem. I'm going to have copyright on everything like this. So this is kind of the thing. So it's absolutely wonderful. Yeah, who knows? Who knows? So we're carrying on with all this, and it's a beautiful thing which you're going to show off. If for people who do not know what I've been working on, I'm going to just go straight through this again. So we're working on, go through the stream even though I said this at the beginning, we are working on integrating the Tilde Backend system for Odin, which is Negate's backend system for his C compiler. So we're going to try and use it for Odin as well and improve it as well. So it's kind of developing for 2 compilers at once, which means it's not mature by any stretch of the imagination. It's full of bugs. Like I've just updated right now and it's full of bugs. But it doesn't matter because we're still trying to implement it and develop it to get what we need, because it is very much where we want to go. And one of the beauties here is this is a nice little compiler system based with SSA, based on a lot of the work, not entirely, but like a lot of the work Click and many of the SSA systems and LLVM and all that lot. So it's a lot of very advanced systems that Negate has been working on. Yes, tilde is Negate's thing. That is correct. Yes, you got a tilde because that's a negation, of course, at the same time. I need to stop with the jokes. These aren't even funny. But yeah, this is what's kind of going on at the moment. So I'm just trying to get stuff working. Now, what this is printing off here is the actual main entry point. So if we go into entry point windows here, this is the code that is being printed. So this is the main function. Again, looks like C code yourself. You can probably see what it's going on. This is argc, argv, and it returns I32. We're doing some basic slicing going on as well. We can show exactly which bits lines of code work. So some of this code is just dumb. But notice, like, this is going to be fast. Like, the Odin compiler is not slow, and we're getting even faster. Like, oh, this is a debug build I'm building every single time, and it's running pretty fast. So compared to LLVM, this would not be any under 20 milliseconds. And this is not even a fully working thing. Did you get 128-bit things to 16-bit? Might have been 16 bytes. Might have been what you've seen. But yeah. But there we go. Now, one of the things I was trying to work on here was the debug type information. So we're going to start implementing all of this. So this is kind of what this IR is. This IR negate I did literally only a couple days ago because I asked for it. And it's good. It's better enough to read. It's better than his graph-viz thing he was doing, where he would output graph-viz visualization, then have to put it into a graph-viz visualizer. And then it was just like, this is not readable. This is some stupid graph. And after a while, like, this is a basic one. I could probably read this. But if I got the equivalent of, say, 100 registers, oh, no, that's a little bit too much and complex. Yeah, we're not meant to read graphs like that. Again, I wanted a linearized thing like this so it looked like assembly. And this is readable to me. So I'm happy enough with that. So this is it. So we can explain what this is. You can see the code here. Here's the main. Is tilde TB? That is correct. Yes. That is correct. It's the same thing. And welcome to that Molnir. Right, so first thing here is the main procedure. This is this thing here. This is projecting the first 0th parameter, which is argc. I'm creating a variable for it, and then I'm storing it in there. So that's that simple. Again, I'm going to load it straight afterwards. It was a bit useless, just so I can put debug code in there for the time being. Create another variable here, which is argv. And then store argv0 into it. That is wrong. Like, very wrong. Yeah, that's very wrong. Why did no one tell me like last stream? Right, so param index. Is param index never gets indexed, does it? No. In fact, I could just do this. Problem solved. And now it should say the correct thing, and it does, yes. We've got rejection. It's just doing it random orders, obviously, it doesn't matter. It's not random, it's just how, if you read through the code, you go like, oh, of course that's going to be in that printed that order. So there's the variable storing. Then we load the values anyway. So then what this does here is adding a local variable. It's a pointer, apparently. It's loading a pointer, and it's 16 bytes. That's a slice, because that's 2 pointers, obviously. Pointer and length. And then we're going to 0 it. Perfect. Then we're going to get the pointer to the pointer element, and then store the pointer element into the variable of the what's it called? Slice. So that's very simple. And then the next thing is we're going to take the v6, which is that pointer thing. We're going 8 bytes across, so we'll go member pointers 80 points. We're going to take v4, which again was the argc, do a sign extension of I64 to it, subtract from 0 because there's nothing in that parameter. That's equivalent of me writing 0 in there. That's what we're saying. And then we're going to just store it into there. So that is now just done a slice. The next thing I'm going to do is just do a mem copy of that value into that address there. That's a store. Big store from this slice to another slice. Dead simple. Yeah? And again, 16 bytes. You can see that. The next thing was defining the context, which turns out to be 96 bytes. Then we're zeroing it. Then we're trying to call this function, but I haven't set up the multiple struct return values yet because that's annoying. I'm just going to ask negate to see if he can do some of this for me. I'm trying to get this working because it's going to take a while just to get the. It's annoying because to get from point A to B, like a lot of the thing is the procedure call syntax shit. Like, sorry for my swearing, but I meant like the procedure call stuff, like the calling conventions, the ABI, how this gets passed, return values, mainly the thing. All of that is actually some of the most complicated stuff to do properly, and how I'm going to have to handle that in the compiler. And because that's going to have to be dealt with properly, I can't just bodge it, even though it's bodging to get things working at the moment. A lot of the expression work is going to be dead simple. This is the funny thing, is the expression stuff is the simple stuff. It's the things that, unfortunately, to even get printing working is going to take a long while. Even if it's just a basic debug print, it's going to take a while. Again, calling all these different functions and then return 0 at the end, because again, it's returning 0. So it's perfectly fine, and it's working. Right. So what I wanted to figure out was, we've done that bit there, but I wanted to go back to the debug type stuff, which was stored here somewhere. So I was filling this out, but we need to find out the struct and union. So a union is technically a struct, not a union. So union in this case means it's a C union, but in Odin we have that thing. So we have to kind of redefine it slightly. So if I go to the TB here, and we have a debug struct, I'm guessing. Yes, so this is the case here. Debug type, and let's call this record. Yeah. So then this is going to be, I'm going to put null pointer in there. So if this is struct.is raw union, because it's a raw union, this is going to be a union, obviously, isn't it? Sorry, m mod. And now we've got a name as well for this. So if I do string name type named name, as we do, it's going to have a lang in there, and then it's got the text, cast that correctly. Okay, so that is the union, and that's the state of that one, obviously. So we've now got the struct going in there, and that's now defined this thing. Pretty simple, as if I don't say my own myself. So then I don't know if this is how we fill in the records of everything. So I'm going to find out if this is even how it works. So debug type fields, and then it's saying defining the type and size and alignment at the end, I'm guessing. I hope this is how we do it. Yeah, it's my hope. So we put in the record type, and then we need to put the count in there. So we need to do bt struct, and then we've got fields and putting count in there. Pretty simple. And then I want to do the end of the record, like that, and then return the record, because we're done with it. So now all I need to do is for array I, we go to the fields, entity field, I, and then we've also got an offset. The other thing I need to do, it's just a sanity check. I don't even really need to do that. Set offsets. Like, I know for, like, pretty much it should be for a fact set up. So it shouldn't really matter. You have that there just as a sanity check mainly. So actually, let's not put it there. Let's put it here. Yeah? Line 690. Was it on this line? Yeah, I mean, it's 16 bits, you're right. I got it the wrong way around. That was meant to be 64. It's wrong, like, it's broken, so I need to ask Negate to fix it again. But, that's not a problem. So, we come into this, we get the TB char units. Type size of, not a line off, I said size of Sublime Text. What were you thinking? Oof. And then we also do a line off for that. Let's just okay, that's fine. So now we're going to just go through each field, shall we? Now, one thing we have to do here, which sounds a little bit silly, is because we've just created the record beforehand to reduce to stop a cycle from happening, we actually need to set the map type ahead of time. So this may sound like a little bit like, what? Have you already done this? And it's like, yes, but this is like weird. So this is what's going on here. So we've got the type and we've got the record. So we have to do it beforehand and then it works. So even though it does it double, doesn't matter. Yeah? So there we go. Right. So we need to go back to TB. We need to create the fields for this, obviously. And then we need to go, I keep scratching my nose. It's just a bit itchy today. Calling convention. No, that's not, that's type. We want the debug type. So this would be the field type. field type, name, and then offset. Okay, so offset needs to be char units, tb char units. String, so let's just do debug, no, tb debug type, so field type equals that. String name, so field token string. So we can put the name in there, so .len. Cast. I'm doing a cast because the way I've stored a string, and I don't know if this was a good idea back in the day, but I'm not changing it, it still works, so, and then put the offset in there. So that's a TB field, but I don't need to worry too much about that because what I'm doing is that, yeah? So that's kind of what's going on here. I'll just put as E as an entity actually rather than field. And line up the names, not the pointers, because that's my style. Why? I don't remember why. I just do it that way. So then that's how we define a struct. How simple was that? Really? Very simple, in fact. Okay, so now we've got to do a union. And the way I think I remember doing a union was slightly different. So we still got together union, but we know it's a struct this time round. Yep. And we've got to set it before we use it. And then we've got the fields. Now, the difference with the fields are they're going to be +1 on top of them because what you've got is you've got a tag in there. Now, the problem is the unions are a little bit weird because if it's union maybe pointer thingamabob, it doesn't have a field count. So field count is going to be, let's call this variant count. So that's bt union variance dot count. Yeah. But if it is that, we only have one, obviously. We just need to do a slightly different thing entirely. So we only have variant count. I'm going to just assert that this equals to 1. Yeah. So it doesn't, and then we have. Let me just think this through. We can then just go through the fields, can't we? Which is kind of the thing, at least. Let's just do it twice, shall we? So fields 0, and then we have a field type. So offset's always 0. The name. So one thing that negates done loud for this is just going to be, that's going to be variant 0, I guess, like underscore v0 or something like that. Yeah. I can't remember what I did in LVM, but it's something like that. And then it is bt union variance 0. In fact, it's variant. Let's call that variant type. Is that v0 or v1? It's technically v1, isn't it? Not v0 because they don't count. No, let's call it v0. It'll be fine. So cg debug type m that. Okay, so the cg prefix just means code generation. If you didn't know, I didn't want to use tb as the prefix mainly because I didn't want to get confused what is the tilde backend stuff and the code generation stuff. So that's why it's the convention. Okey-dokes. So we could just keep it as v. I don't know. We'll be fine. So that's that done. That's dead easy. But the rest is all fine in my opinion. So then we just have to have the variant count in there, obviously. And now we can do an array. BT union variance. So then we have type of the variant, obviously. And you think maybe you could have just unified this code. And the thing is, I probably could have done. Chart name, let's say 32. name, gbsm printf, name, let's say 31 in there, and then it's v sent t, let's just do d, or u, whatever. Cast u32 of I. Yeah. Okay, now I know why I split it up, because technically you need variant counts plus 1 in this particular case. Because you need to also store the tag. Yeah, makes sense. So that's that. They're all offset with a different name. That's fine. So then all we need to do is this is the tag. Tag. That's not at offset 0. That is at variant block size or something like that. Let me just check what it's actually called. Tag size, no. But we do need the tag type. So the tag type is that. We need to put the union in there, and then we need to get the debug type. Like that. And then there should be a union somewhere, and it's tag size, yeah. Variant block size, I was correct. Bloody hell, it's kind of scary that I remember what it was called. And then it should be all done in this particular case. This is no tag. And then these don't even care about if they're whatever here or anything like that. Now it could be that we could plot a +1 on here if there's a thing. B index, so we're going to cast that as a U32. If BT union no nil, I think what I'm going to do with no nil, then we can do that, right? Now it's got some, that's meant to be an assert, not a panic. Whoops-a-daisy. Woohoo! Right, no nil. Is no nil, I'm guessing. No, what did I call it again? Union kind. I don't know where that union kind is. Is it in the parser? Yeah, it is. It's just no nil. If that doesn't equal no nil, then it's going to have that on it, yeah? I doesn't exist, apparently. What? Yeah, here. I didn't mean to do that. That's just a variant count. It's the last one, obviously. And then it says, oh, we can't do that because we must cast that to the right type, obviously. Char units. And then it says V. Apparently we don't pass the typing correctly because I'm a numpty. But now it's working with the debug type. We're not even using it. So there we go. This stuff isn't best in the world necessarily. Is it music? Oh. Can you hear me? It should be coming through as well. Still no audio? There should be audio. Hello? Right, I can hear what you were saying. Like, oh, there it is. Don't know what didn't do anything. Did not do anything. Whatever. Right, all I'm saying is yes, the last parameter is the offset, and for a union it is always 0 because it's the first element and that's how it's defined. So hello, indeed. Right, so I'm doing this as a base type thing just to recursively go through things. Right, the problem is the record size in bits or is it in bytes is what I want to know. That's the fun bit. I'm guessing this is size in bytes. I'm hoping at least. And now it's asking for BT, but it isn't BT, it's just type. Like so, and that's it. Now it's crashing. Okay, online, the debug builder. So it's crashing somewhere. For which type? Create field. Name. It doesn't want to be an empty name. Shit. Yeah, that's never a good sign. So an empty name for the struct stuff is not a good idea. So if name.length equals 0, what we're going to do here is just say it's underscore. I think that's probably not a bad idea. So the language you can write in the compiler into C++, but stuff like, okay, so now it's still failing? Why? And where is it failing? Internal record, name.length. So name is empty. Because of course it is. Of course it is. Because that's not even the right bloody thing, because I'm writing the wrong language. Look, this code doesn't even need to exist. Okay? And I can end the record here. Return record. Perfect. Now it's working. Wonderful. That was my stupidness by accessing like crap stuff. Yep. Which is nice. This is all working as I expect. So this is great. This is still not finished, by the way. We still have a bunch of other data types to create, like a string, which is again a record at the end of the day. So are all of the complex stuff. So shall we do that? No, the tag shouldn't be 0. I didn't put the tag as 0. Look, the tag is at the block size. Yeah? Yeah? So it is the correct place. It's just because this is the size I normally deal at. So it's absolutely fine for me to read. You guys can't even see it because it's so tiny, yeah, like that, yeah? But this is just so that people can see it on stream, obviously. So it's a little bit too big. Yeah. So let's fill out all of these basic types because these are technically struct types. And we can fill in the debug stuff as we go. So complex element type, like so. This is type, type, let's call it lm for the time being. And then we need to create another record again, but this time is named, so it's fine. Record, no, what was it, TB? Create another struct, I guess. TB debug type record. Mod, the length, I'm just going to put as string name. In fact, TB debug type, that's the element type, so TB debug type, not TB, so it's CG debug type so that. The name of this is where's the basic stuff, guys? I don't remember where the basic types are defined. Even though I wrote this compiler. Yeah. So they've got the basic types and they have all the names at the end. Basic types are type basic kind. Type. God, where's the basic information? Here. It is just called name. So, well, that was dead simple. So then when we come to create the type, we have name.length, cast char const star, name.text. And that should be enough for the fields, isn't it? That's it. Your name and tag. That's it. Done. So that's your record. We can then begin it. TB debug type fields. We have the record. And the number of fields we've got is 2. And then we can just set what the fields need to be because we know what we're doing. We can then end this. It's going to be the record. And then we've got to do the size and stuff here, haven't we? Like that, yep. So they can always just do this twice as well to get the right type. So now we've got the size and alignment in there. I don't have to rewrite it every single time. So size, align, and then we can just return the record when we're done. Yeah? So then we can just fill it in that little field. Little field, that's all we need, man. We have the LM type. We don't have the name, or the offset, or the whatever. So the name, I'm just going to do that. I can't remember what we're calling it, but I'm just going to call it real? I'm guessing it's real. I could probably put multiple fields overlapping each other. Probably not a good idea though for this particular case. Element size is type size of that. Then we've got to cast it to the correct data type. Loads of casting going on here, but that's absolutely fine for the time being. So 1, and that's I am imaginary. And that's going to be like that. So that is for the complex numbers done. So then quaternions are actually different. I'm just going to do a quaternion layout. And I used to do this as a little trick here because the layout of a quaternion is a little bit weird. As in the imaginary number is first. So J, Maj, K, Maj, real. Now let me just check what the LOVM code did. Quaternion? No, it's LOVM utility debug type? No, is it LOVM general? Debug? No. LAVM backend in general. Oh god, where's the debug? Oh, LB debug type. And it's defined here somewhere. It's under debug. Who would have guessed? That's fine. Complex 32. So the fields of column was real image. Yep, and then I called them all that way. That was correct. Okay. So I did do it correctly this time. Yeah, so that's 0, 1, 2, 3. That's the quaternion stuff generated. And now I've got a typo in this bloody file, and I shouldn't have done. Type size of. Whoops, that was a double copy and paste bugs, and probably somebody already seen that. Types, basic type, basic name. And basic name. So again, this is not technically tested, but I'm pretty confident about this. The same thing with this string thing. Now, what's interesting is that these, yeah, same with the string stuff. I can do the same thing again. It's going to be 2. Wait, what am I doing here? No, I meant to do it on the string. So the string, there's going to be 2 of them, only 2 fields. So you have the data pointer and then the length, obviously. And those are going to be both pointer sized. No, int size actually. I'm lying. Int size. So build. Is int size defined at the top here? It probably isn't, but we're going to add it. Int size. And then we have pointer size in there. Okay, so we can go back into here. We've got the data, the length, and we haven't got the types here yet. So what we need to do there is define the types for each of them. So this is a uint pointer, and the other one's just an int. The int. And then that should be added. And now that's added for the basic. Now we've got to do the any again. Not again, we just have to do any. And then we have ID. But these are pointer sized, so they're actually a lot smaller. So this is a raw pointer, and that's a type ID. Yeah? That was easy to do, the any. The type ID is just an integer, obviously, and then we're done for that. And we're getting there. We are getting there. Let's copy and paste this. Because then we've got to do the slice now. So there is no name for the slice. So I'm just going to put it as empty for the time being. But I don't know. Quaternions are an extent. Oh, I'm just reading the questions through there. So we're working on the Tilde Backend for Odin at the moment. That's what we're currently doing. Quaternions are an extension of complex numbers to the 3D space, right? Kind of. So complex numbers can represent rotations in 2D space. Yes. So quaternion can be used to represent orientations in 3D space. Yes. You're right. Sorry, someone else pointed out with the quaternion thing. That's still set to 2, not 4. Thank you. Just literally copy and paste errors everywhere. Look at the slice. This is data and length again. Data point is going to be alloc type pointer, which is not going to be the best thing in the world. Type slice element. The next one is the thing. It's not the prettiest thing in the world, but there's no name for this. So, but do we ever actually generate a name for slice is what I want to know. This is so big. I don't need it on the... We've got a massive screen and I can see this and it's like, oh, this is huge. Like, yeah, it's very big and I don't really need it this big. I hope it doesn't need a name. We'll find out later. Dynamic array, that's going to have 4 fields in it. 2, 3. So that is going to be the cap. And then you've got allocator in there. So we have 2, 3. And then that's going to be T for allocator. You can get it kind of lined up, but not perfect. Hopefully they don't need names. The map type is different because it does have an underlying structure to it. So we can actually just do the map type. So T map, no, raw map. So each map is identical in this case. So it's just a CG debug type of raw map. Yeah. We've got the struct type being procedures we have to do next. Type bit sets are going to be fun because it doesn't really work with this system yet. So we needs to keep extending with all data types. Do you get any speed up from having quaternion as a language feature, or is it mainly convenience? Bit of both. So you do get some minor conveniences because clearly it's in line directly, no problem. But in general, it's just mainly convenience, and also it's like it's there. It's nice and useful. Does Odin have its own IR? Well, kind of we're doing that right now. So, yeah. Yep. So, bit set is technically an integer. So, we want to just do CG debug type bit set to int. Like that. SIMD vector is technically a thing, I think. Debug Debug. Let's say debug array, shall we? Because it kind of is, but it isn't at the same time. We need a base type, so that's going to be CG debug type of mod, whatever the element type is. So type simd vector elem, and then we got t simd vector count. Now it's not technically correct, but that's not fine. That's fine. For the relative pointer, it's just whatever the relative base integer. It's the same with that, so that's just another copy pasta. Both of these are just integers. So, what we need to do here, God, there's a quaternion layout everywhere, which is not even quaternion layout. That's quite funny. Right, SOA point is another thing in the matrix. Is just going to be an array as well for the time being. So that's fine. I'm just filling out the debug stuff, and then when we come to do the procedure stuff, which is here, yep. So what we need to do here is fill out the relative slice information. So debug type of whatever the type relative slice base integer is, like so. Put that in twice, and then it's not even int size in that particular case, is it? That's going to be bi size. So we need to be tb char units bi size equals type size of that cast by that. Okay, that's fine. We have a matrix, which I'm just going to pretend it's an array for the time being. Matrix row times column. And then SOA pointer is technically a pointer plus a length. So it's the same as like having a slice, but a bit dumber. That's technical terms, that is. Slice, but dumber. Quote me on that. Right, so then we've got this here. SOA point. I don't know how the SOA pointer works, to be honest with you. Let me just check. SOA point. It's one of the weirdest things when you think about it. It's the element type. Yeah, it is just weird. Like it's a pointer to it, but then we've got an offset. So this is the offset. That's the pointer, and these they're both int sized. I think, yeah, they're both going to be int sized. Yeah. Oh god, I've now got all this other crap. I don't need to put that in there because that's just a typo. So is all of that. Base integer is apparently not a thing. It's pointer, that's why. Row times column is not a thing. It's row count by column count, obviously. Duh. That's not even technically correct. Shit. Because the stride has to be there, and it's like... So how many is it? Matrix... Total internal elements. Well, there's the correct type that I meant to use. Count is that. So if I put type, count, cast, no, we'll just put as that. That should work fine. And now it says there is a nothing there because that doesn't need to be returned. And then debug proc type proc doesn't work, which is wonderful. We're nearly there. We're nearly there, guys. So close. So close. Right. We need to generate the procedure now. I don't know how this is going to work. We have a debug func. Got the debug func. Type debug type. No, create. No, debug create func. Now my problem is this just a func on its own, or is it pointed to a func? This is where my question lies. I'm going to find out because C is different to many things about this. Mod tb debug type func. Got a calling convention to it. I think it's just tb calling convention, whatever. Oh, it's tbc decal is what I want for the moment. Yeah, for the moment. And then what we have is the parameter count, and then the return count, and this is going to be fun because we have to figure out what we're doing for the param count, return count, and then type proc pt type proc pointer pt is c vararg I think. This is going to be fun to calculate, I'm going to tell you that. Okay, so that was actually compiling, surprisingly, but that's interesting. I don't know if this needs to be a pointer or not, and if I need to predefine it for the type or not. I think I probably should predefine it. And the reason why I'm saying that is because of cycles. I don't know if this is a good idea or not, but the problem is, it gets a bit weird, I can tell you that. For instance, let's say we have a struct, right? We're defining the struct internal here. Yes, it'll be here. Let's say type equals, let's get rid of that, that's stupid. If is type proc, I'm not even joking, I'm just going to get rid of the cycle and just put in raw pointer in there and do it that way around. Because I have an inkling that's going to happen. And we're going to have to do the same thing for when we do a procedure. Yeah? That's what's saying the question, so yeah. What was motivating the right? The Tilde Backend, some node camp analysis things. So that's partially it, but the main thing is LLVM is bad. LLVM is slow by a long stretch. It is buggy. It keeps breaking with each new version. It's poorly documented to the point where I've honestly seen people say, oh, how do you do the calling convention API stuff in Odin, not Odin, in LLVM, and they point to the Odin codebase. Yeah, this is when it's bad, when they're pointing to me for documentation for LLVM. Not good, is it? Did I say it was buggy? Yeah. Especially since it assumes C and C++ like semantics, so when your language doesn't necessarily adhere to them, whoops. It's not worth it. It really isn't worth it. Like, if there's anyone out there listening right now who's thinking about making their own language and they want their own compiler backend, don't touch LLVM. Just make your own. Literally, make your own. Like, Tilde's not usable yet, but we want to make it usable for people. But, like, just don't. I'm not joking. Don't. Well, yay. Okay, so the procedure stuff is fine. Like that's not even ready yet, but like we're just going to say this is fill in CG debug type, or mostly fill in. It's going quite well, quite well. So we've got working on the debug information stuff. So I've got most of it done except for the procedures at the moment. I'm not particularly sure how I meant to do the procedure stuff, Negate. Like I've got the function parameters here. And I'm guessing this is you're describing it as if it's C-like. So this is where my question is the debug type for a function itself or a pointer to it? Like, am I actually meant to return a pointer of this? Yeah? And then this is the actual type I'm meant to return? Now, I don't know. I'm not testing it out yet. This is where I'm saying, like, oh, is the function this or that? The other thing I would also, when you go, let's say debug type, is that completely opaque? Yeah. The other thing I was wondering is if this is the case like this, where am I looking at? Here. One thing I might be asking for is the ability to just, if you got a debug type, can I just get the basic one so I can always get it back? It's the function itself. You should be making a pointer to it really. As I'm really sure that's how code viewer would treat it. Yeah, that's why I'm thinking of checking. I think just doubly checking. Yeah, that's fine. So I need to find a way of dealing with this in a bit. So I need to return the function pointer, but once I've dealt with all this, it's fine. Now I'm guessing I need to figure out how I'm doing the parameter stuff. Because this is meant to be C-like, so it's okay. So we will... The tuple stuff, actually come to think about it, should be pretending to be a struct. So wherever the struct code is here, we can pretend it is a struct. Okay? I'll explain why I'm going to do that. Because then when I go back to the record stuff for here, I can pretty much copy and paste the exact same code for a record, for a tuple. So we go to here, tuple. It's always going to be a struct, so we can get rid of that code there. There is no record name, but that's fine. This has none in there. In fact, I can always just go record name.length equals 0. And we can assume that this is empty for the time being. For the time being, at least. Field, so struct, this is tuple, variables count. Then we have the offset, which is, the offsets are tuple offsets, I think. That would be that. We get this here, and then we've got a record. So that's our tuple, pretending it's a struct. The reason why I'm doing that, and it will make perfect sense when I get to it, is when I'm trying to do the calling convention stuff for Odin. So the parameter count is actually going to be fun to calculate, because I have to look at how the Odin does it currently. I believe if this is meant to be like C, we will need the number of parameters we currently have, which is not necessarily all of the parameters. So I have to calculate this. So for entity E in, first off, if pt params tuple variables, so that's the first tuple. If e.kind equals entity variable, then the parameter count goes plus equals 1. That's all of the parameters now we're done. Oh, and then we also need to doubly check the return value. So if the pt results, now we know there is a return value, so that's fine. But the other thing we need to add on there as we go along, and then if pt and then if is calling convention Odin for that type, we actually have to add a parameter count to that, add 1. So this is the context implicit. This is just the context pointer or putter, whatever. Yep. Does that make sense? So we're going through all the variables, passing them all one by one because that's how it's going to work. That should be fine. And then the results is where the fun bit comes in, because if it's an Odin calling convention, we actually split them all up. So if it is the Odin calling convention, let's just do a Boolean here. Is Odin CC like that? If it's Odin CC, then what we need to do is PT results. No, we can always do result count -1, or param count +1. Yeah, and then return count is going to be equals GB max of that -1 of 0. So now I've got the same kind of result, if it makes any sense. Yeah? Because if there's 2 here, we're only going to pass 1 by pointer. But if there's only 1 there, nothing gets increased. But this is then going to be, if there's only 1, oh good, yeah, there's only going to be 1. That's what I mean, yeah. That's what I meant by 1. Which, yeah, that's fine. No, return count is going to be, oh god, no, it's going to be 1. No, it's going to be, if it's greater than 1, no, if it's greater than 0, it's going to be 1. That's what I mean. Oof, I couldn't think of the logic through there. Okay, what's this little bit of code? Thank you very much. For the parameters, do that. The field name, the offset's fine. Wonderful. Wonderful. So this is what I'm doing here. And then if there is a return count, the return count is going to be 1. Yes, the return count here we know is going to be greater than 0, so it should always be 1. So that is fine. So this is how many the parameters we've now got. So that's exactly what we're trying to figure out. So this is now the parameters. So TP debug type params. Okay. Like so. And then we just need to do the function. And then we have, we all call in this returns for the time being. So let's call that. And this is where the fun bit's going to start. Okay. We need to go through this list again. So param count equals, let's do param index. Easy. And then return index as well. Yeah. There should only be 1 in there for the time being. I'll ping you if there's problems, don't worry. Yeah. So, we know this is the type and the name. So it's just a field. Param index plus equals create field. So this is the module. Type equals CG debug type. Now the problem is we could technically get into a loop here. This is half the problem. So this is where I've got to be careful. So e-type, no, it's just yeah. E-type, if is type proc, then the type is going to be a raw pointer. Yeah, like that. That's how we get round the loop things, because the C-type system cannot describe Odin. So a good example of this is, let's say we have a procedure foo, returns foo. This is impossible to define in C, but perfectly fine in Odin. A good example, let's try and define this in C, right? So we go like, okay, we've got a function pointer. So it needs to return foo. And it takes a parameter that, it's a pointer, and then so it's a function pointer like that named, can you see the problem? Yeah, you can't define it. So in Odin you can, but in C you can't. Welcome to the problems of C, actually. So then we need to get the name. So string name token string. If name.length equals 0, we can then put a debug name in there of, like, say, an underscore, because then it's still valid. Name.length, name.text, cast chart const star, and then 0 in there. That should be perfect, yeah. So that's that done. That was simple, wasn't it? This is where things start getting a little bit more complicated. So, if there are results, we're only going to do one of them. So, we need to do this. Yeah? But we need to do a different type. So, it's where it starts getting a little bit fun, is the best way of putting this. We need to get the results again. So, we need to go through the entities. Like that. Well, we don't need to go through all of them. So actually, let's just do a manual for loop. Yeah? Whoops. What the? I didn't do anything then. The -1 plus plus. We're doing assert there. It's not params I want results. I've got a typo above already. No, not typo above, just typo there. So make sure it is a variable, which it should be. Type equals e-type. Now it's going to be a pointer to this. So these actually do have their names in there, but they're all like return values. So if e.type equals, oh no, if it is a procedure again, yeah, we're going to just do type t raw pointer and then type now equals alloc type pointer type, because it has to be a pointer to it. These are just return values, yeah? And then the return count is just the actual return value is going to be whatever this is last. And it doesn't, they shouldn't be named. I know they shouldn't be. So when you do the last one, it doesn't need to be a field, does it? It just needs to be a type, I'm guessing. Return index plus plus. Last type. Type. And then we want to do the same thing again. If this is a procedure, return a pointer. And then CG debug type. I'm guessing it is this, by the way. Might not be. I'll find out. Otherwise, the last thing what we got to do is a tuple. And we just take the PT results. Now, what I'm going to do here is assert that the param index equals the param count. And the return index equals the return count. Yeah? That's a nice little sanity check that I do for myself because unfortunately, right, that's not even a function, is it? Yeah, I think I need to do it that way around, don't I? So now it's built, but it doesn't mean it's correct. I have no idea if it's right, but it's fine. It's got to this point. So one thing I might do is, you know, when it defines like the map and we define it early and do all that crap, we're going to do that as well for the procedure. And we do it properly early. So we have to do this. Yeah, so func pointer. And then we've got the original type. That. I mean, I could always just write a type original here, so. Yeah. And that's fine. So I'm just doing this. So it's the original type. In fact, it is the type, but let's just do type, yeah, because it will do it later. So when we do call it, it'll get the right thing, I hope, and just do original type as well. So this is the thing. And let's find out how else this works, shall we? Does this ever actually get here? Now, is there a debug way of printing these debug types? Yeah, I don't know. It's going to commit this changes, obviously. Debug, implement debug type for procs. Yeah. It's going on well, isn't it? I think it's going so far. I think it's fine. I don't know. Do you know some guys? I don't know. Rightio then. So hopefully this works, is all I'm saying. I hope. Do you see Tilde become the back end of choice for other languages? Well, hopefully that's our plan. Well, my plan. Well, not necessarily our plan, but it's what I hope for Tilde, because it's not mine. It's Negate's. And I hope it does, because it's one of those things where we need an alternative to LVM, and we need a decent one, and we want one that can be used as a library as well. It works on like Windows, Mac, and Linux. Supports ARM64, AMD64, and hopefully WASM. Like those three alone, what I've described is not like a big I say it is. It's not easy, but it's not a asking for much requirement, and as such, it should be fine. Yeah, that's kind of what we need. This is the thing. We need this. Like, unfortunately, we need it. Okay. So we can get the debug type thing, and I need to get the base type as well, I think. So what I'm looking for is, let's go back to the Tilde Backend stuff. Tilde Backend here, debug types, and this is going to be the proc debug type map. So not pointed to. Now, I don't know, this is where it gets a little bit weird. Type proc. Does it actually store it on here or not? No. That's good. That's a good sign, that is. We have another map to actually set up. I need to reorganize this code for the debugs to source. I need to put tilde debug and put it in there now. Where was I putting the proc stuff? Here. Yeah, let's do both. Original type, no, just original type. And that's absolutely fine. Okay, so that's starting to get there, by the way. So like, I'm going to just start refactoring. So I'm going to add a new file. Tilde debug.cpp. In fact, I'm going to put that there, I think. It's a better way of putting it. Rather than in the statement file, tilde statement. So I'm going to make this smaller because it's so flipping much code that I just want it to be able to read it. Okay, even if it's in its own little file and that's it, that's fine by me. So now I'm just going to commit that file. Tilde debug. Move debug type code to its own file. Okay. Love seeing that Sublime text. Really, is Sublime text that popular nowadays? Wow, who'd have known? Okay, so because we got the debug type stuff here, and what I need to do is another function. So this will be the Oh no, wait. Is type proc is better what I was looking for. We'll do this. And if that's the case, then we're just going to do another mutex lock to get the value. And then what I need to get here is the func. Get that funk. Get that funk on, man. You know, the thing, man. Right. So, let's do this. And then we were going to get that map, get proc debug type map. And it's that type in there. And that should be it. So it's func found, I think it should be the case. Func found should be new, and then it's just func found. Okay, so that's that. We've got the debug type for proc now. We're nearly getting there, by the way. Hello, does tuberculosis backend compile all code successfully and faster than LLVM yet? Oh, it's a brilliant code. Thank you for asking. The answer is, of course it does. And it's consumed us all with the consumption. So if we cannot do it fast enough now, you'll be fast to the grave. That's all I'm going to say. So, okay, glad to see me back streaming. Thank you. I'm glad to be back. I've just got time to do it this week. Right. Let me see for the tilde proc. And then we have the proc type stuff somewhere. Creating a proc. Oh God, this is where I'm going to see how we did it. Create func. I saw there was function prototype. Set function prototype from debug. Okay. And what does this? I'm confused with what this function is meant to do, so I might have to. Yeah. You guys can't see a fucking thing, can you? It's all right. I've just been moving code around. I've not actually been programming. But yes, yeah, it's one of those. Good God, that's been so tiny, teeny tiny. I hope this is better. Is that better? Is that size okay? I'm trying to figure out what sizes people want. Okay, so I need to figure out this. So you create a function and you can set it from. And what are these nodes that return? They're just the parameters, right? We have set prototype here. And we can do create procedure. Yeah. So we can get procedure type as prototype was my code here. But like, params, there's a lot of them. Param count. So we have the function itself. So pfunc debug. We have an arena. And then we have that parameter. So the debug type, which is actually no, I won't do short. I'll just do debug type. Tpush debug type, and that needs to be CG debug type for proc, and that's the procedure type. Now we need to add that to Tilde Backend. Is here, and we've got type, but we need debug type as well. So like that. But now we've got the debug type. I actually want the actual type, this actual prototype. But like it real big, do we? I don't know. So when we've got this going on, get it on. Function. It should have. TB function is... Like, okay, let's say function proto. I can get the function prototype. So I'm just going to do that once I've created the thing. So proto is the func, like that. So I don't need to set it anymore. I can just copy that shit out. Does this get called anyway? It gets called here in the dummy. And it gets called in the make call, which is... Oh, right. That's going to be fun. This is all wrong. So eventually, I think what I need to do is... Oh, shit. Yeah, this function's bad. Yeah, it's good to set it, but I want to just be able to get the function prototype from the debug type. And that's it. So... Ah, shit. I need to DM him. Yeah. Yeah, so I'm just DMing him, so that was fine. We'll figure this out. It's fine. If it's busted, it's busted. You wonder why the debug types are generated as needed instead of together with the actual types. What do you mean? Does TB translate Odin to C? No. Tilde translates directly to machine code at the moment. Again, it might be, we might go lower to C eventually, which is kind of funny when people say that. It's like, we'll go eventually to C, even though usually where people start with. But no, we'll probably go to C eventually because you probably can do it, but not yet. It's not, oh well, it's just we could make a C backend for this quite trivially. I'm not even joking. If you look at what the instructions are, they can all map to something in C. There's a bunch of things which... Yeah, there's a bunch of things we could do. I could probably write it myself. I'm not doing it this week though, because I want to do other things. I want to get loads of things done first before I start fanning about with other things like that. Okay, so that and that are gone. Put that back in. P-type should be correct. Oh, I've got the module in there as well. Mod. What's wrong here? Oh, it is just a normal mod, not seat mod. Okay, this one's a little bit weird. Undeclared debug type. Oh, it's p.debug type. And again with this. Param index does not equal param count. Oh, that's fun. What did I cock up here is the question. Zero equals 1. Say what? The param index. This is where things should be correct, but what is the type? Type to string of type. Or empty proc, which is correct. I didn't ever actually add the context pointer, did I? So if is type is Odin CC, is that actually whatever? So if PT calling convention is Odin, no, is proc CC Odin, then what I need to do now is add the context pointer there. So that's why I was missing one. The name I'm just going to put here as name.stringlet, And I'm just going to do it similar. I think what I called it in LLVM was not a great name, but it worked. So, whoops, it was like dot context putter. Yeah, or dot context or something like that. Yeah, that was the name. The type is t context putter, and that should be correct now. So we're adding the stuff in there. That should be type. That should be whatever. So this is now contextless as a type ID. Is CC is not correct. We need to check it just for the context case. Now it's working fine. That is actually pretty damn bloody cool, man. I will say that is pretty cool. But what's interesting is it generates those nodes. So I want to just say these are the parameters. So looking through the code again, sorry. Let's look through the chat because I keep getting distracted by it while programming. It says, okay, so I've noticed that languages that try to build on top of another's VM runtime compiler tend to struggle. So F#, CLR, closure, JVM, yeah. Camel, Beam, yeah. I'm interested to see how this works out. So, okay, that's fine, yes. Okay, that's a small moose. So another bloke is saying, okay, so when creating type X, generate the debug type at the same type instead of when needing the debug type. Yeah, that doesn't happen. That's not how it works. The type is generated within the front end, and we may not need that type. So there's no point to generate the debug type there and then because we may not need it. So just generating it then is not necessarily great. That's what I mean. Like, we're not just generate it when we need it in the back end. It's kind of the back end stuff. It's fine. We generate it, but we cache it. That's the whole point, is that when we ask for the debug type, we check to see if it exists already. We take that, and if it does exist already, wonderful. If it doesn't, we generate it, then just cache it. So it's very much a caching system in that regard. So what was I looking for? Yeah, so we've got the debug stuff here. So this is flesh out procedure, debug procedure type. Push. Oh God, why is this not pushing? Thanks, GitHub. Don't tell me GitHub's down. Just ignore abort, it'll be fine. What else was I looking at yet? Oh yeah, there was some other things. So this is fun. I wanted to go to the Tilde Backend, and it was like params, because they were like param nodes. So like that, which like most of this is probably going to change, by the way, but we could have always just made this a slice. What am I doing? Param nodes. Let's call them param nodes. Problem solved. Beautiful thing. Beautiful thing. Yeah, let's do this. So, when we then do this, we get the parameter nodes here. So PD param nodes. So we then do slice make. Oh God, where's the slice stuff? So slice make. That's not what we want. Slice from array? No, we just want a slice, don't we? So I'm just going to put params in there and out that and cast that to an eye size. And hopefully that works. It does cast correctly, so that's great. So when we come to do the main thing, so begin procedure body, we can actually just go through all this. It says param count on this, that's fine. I think these nodes are what we want. So if I do that, Yeah, that's correct. So that worked. Pretty cool, right? Pretty cool. Pretty cool. Yeah. These are adding all the local variable map for here. This is all just dead. I don't even know what's going on here because the problem is I don't know all of the information. Like I don't know if this is a like what's the debug type for this? Could I get from the debug type to the original type to figure this and this out? No, the information I need to know is this direct or indirect or been ignored? And we don't have that information yet, which is annoying. Yeah, a TB is intended to be general purpose. It already is, technically speaking, as it refrains from making too many assumptions like LLVM does for C++. Yes, correct. It can do C assumptions, obviously, because it's being made for the quick C compiler. But like, I want it to, there's many things I want from it, like saying, hey, could you just not assume too much like C as much as you possibly can? Because that'd be nice. That'd be very nice if you can. Thank you. Thank you very much. Yeah, I'm about stopping there with the stuff. Because the parameter nodes things here is very different. This is going to includes parameters and it's parameters pointers to return values if exists. Oh, and context pointer. Yeah. Okay, that's fine, I think. So we could always just do that. Should be doable what I'm thinking of, but like I just need to stop. This is the problem, is I've gotten to the point now where it's not blocking me, it's just there's a lot to figure out how to do this because it's all to do with the procedure call stuff, and I'm just going to go to the full camera now to explain it. So I can just talk to the camera, obviously. Hello, camera. How you doing? But no, the stuff at the moment is I've kind of figured out, well, if this API stuff works as it magically does, which is what, oh my god, if it does, another problem with LVM doesn't do, solved already. What I need to do is go from one parameter to the real thing. It will just, and then also need to know which other things I need to just as things other. Because that'd be fine. Once that's all sorted, yeah, so I'm just thinking out loud, and should be doable. Most of this is fine. So with all of this, with the procedure stuff, it should be fine. So I'm going to go to bed in a minute. Because then I might be streaming again tomorrow, randomly, whatever time of the day it may be. But I will be doing this, and oh god, this will be fun. I'm just trying to think, how do I deal with this? Just trying to think, what is the plan for tomorrow is what I got to deal with now, because it is procedure stuff, but I don't want to touch this too much if negate is changing a lot of it, is what I'm trying to say. And he probably is changing a lot of it, but not all of it. So that's one good thing. The other thing I'm going to be asking is, once the procedures types are in there, we need to know if it's direct, indirect, or they've been ignored, the parameters. Then we also need to know what else do I need to know? Once that's done, I can then probably start dealing with the actual return values as well as calling stuff. Then I'm going to have to deal with the tuples. And they're not really tuples. What I mean is multi-return values. So multi-return values, there's going to have to be two ways of doing it. It's either going to be pretending to be a tuple, or it's going to be pretending to be a struct. And when I mean a tuple, I mean this is disparate values. So this means there's going to probably have to be a we could probably be a struct. This is the things I would have to ask Negate. How easy is it to optimize this out is my question. And I don't think it is. This is the thing. So let's say you got a struct right here. This should be okay in like, oh God, how do I do it? How do I do it in LLVM? And it might be shit. This is the problem. It may actually have to be shit. This is the thing, is full internal. It is pretty shit. Yeah, that is pretty shit. You can't see what I'm looking at. Let's go back to the scene. So there we go. So all this shit pointy casting going, things going on. There's the actual call. There's a ret. Ret is going to say, you have to do sret attributes on there. It's also saying it needs to be inlined or not inlined. That's fine on the call site. And then it's got the ABI return type. Where the fuck is that defined? There. So when it goes to return internal, it's got, some of them have the ABI return type and some of them don't. Like here's the return type. Reduced to a tuple. Does it have split returns or not? That's a good question to ask. If it does have split returns, we need to do the partially processed args and then pass them to the things to be done with. And also add the context pointer when we need it, obviously. And then reduce this last value to a single type, and that's fine. So then once, if the original type doesn't do that, yeah, so that's what I do. Okay, so it does the fixed tuples thing is what I did last time, which is the question is, should I do that? Because that was a complete bloody hack. So I'll explain the logic, okay? You can probably see on the screen here. So let's say you've got a function in Odin, or a procedure, whatever you want to call it. And let's say it just returns 3 values, right? Like this, yeah? So it's 1, 2.3, and true. Yeah. The way that we've now defined this, and what I'm going to do is say this is contextless as well. Yeah. So in C, the equivalent of this would actually be, you got a B32, you got an I32 pointer, let's just call that R. Let's just know this, call that return 0, and then we have a F32 pointer return 1, right? So then effectively, oops, this becomes R0 equals 1, R1 becomes 2.3, and then it returns true. So I'm just doing it in C for people to see as well, understand it. So then on the other side, what happens is a little bit weird, right? So it's really shit at the moment, and I need to improve this. This is where I need to think the design decisions to come in. So what we've got is, when we call this, we've got B32, and this is going to be R2, I'm going to call it. So we say foo, we have R0 and R1, yeah? R0, this is getting in C. I remember I'm just doing this. These all get zeroed. So that's all fine. Let's just pretend this is C. Syntax is C. And then what we do is because it was a tuple, we pretend it's a tuple everywhere. So we create a new struct which has all of those parameters in, right? So we actually just go, oh god, should have got the type in there as well. And then this is the tuple effectively. Now, I'm not saying this is the correct way of doing things. This is only in certain cases when you need to have this fix up. It's absolute, just a complete dummy fix. And then we eventually just don't even use it. This is the thing. It's kind of a pretend it's there, use it as if it's a tuple. And then when you come to use it, we don't even use it. So it's kind of a, just, it's a fix. Like if you read the comment here, it says, result pointer is a dummy value which is only used to reference a tuple value for the tuple fix. The reason for the fake stack allocation is to use a unique pointer for the value and use as a key within the procedure itself. So it doesn't actually do this. So even though we pretend to store things like into here, like doing this, when we come to use it later on, it gets referenced. Now this is a complete fucking bodge. But this was only because of how the compiler was written previously, but also with regards to how it was also to do with how everything else is working. So I think I'm going to change this how it works. It is a dumb thing, but if you see a tuple, it shouldn't be that. Oh, technically TB does have multi-return values, but not really. No, it shouldn't support it because there are different, how do I put this? Different APIs will have different multi-return value stuff. So when it's Odin ones, yes, we do the split things. When it comes to C, we don't, we pretend it's a struct. Like we're just returning a struct. And the reason for that is because in certain APIs that has to be the case, and certain things it doesn't. So you don't know which ones are which in that regard. So you have to be very careful is what I'm saying. So this dummy thing is shit, is what I'm saying. So we in the compiler, I need to put a dummy value in there and say if we come across an expression and it's a tuple, an actual tuple, like the CG value here is going to have to contain a null pointer, which has nothing in there, by the way. Or it could be not a null pointer, but it could be something in there, whatever. So it just could be, this is a CG value tuple. And in there, we have the type of the tuple. It's not a tuple, but you know what I mean? Like, it's just the type. And also all of the values. So we have the values, so like R0, R1, R2, coupled with the tuple type. It's not really a tuple. Again, I keep saying it's a tuple, but it's not. It's a fake thing. It's not really there. So then when we pass this around, it actually checks to see... It's only ever going to get used in certain contexts, is what I'm saying. Like, when it gets used, it's going to get decomposed anyway, because it's come across like, oh, this is a tuple. Okay, so then we get the values and we broadcast it to where it needs to be. So this is probably the best way of doing things. So we have to add a new type in there that actually stores all those values, even though it says, when we come across and it knows it's a tuple, it's not a real type, we now know there's multiple values, so then we can bring those multiple values out and deal with it. That's the way I'm going to deal with it. Not the way we previously did it, because that was fucking shit. But this one doesn't have a real value in it, so it's fine. So that's the way to deal with it, I think. Yeah. So whilst I'm here, type no, it's going to be tilde backend.hpp. Yeah, here we go. We've got all these different values, and what I'm going to have to do in here is a tuple. Yeah? So it's got a type, and then it's in this pointer thing here. It's going to be the CG value tuple nodes. Yeah? And we could just do that. Yeah? Tuple nodes. It's technically multiple values. It's not even, it is a tuple, but it's not a tuple. Yeah, whatever. It's not a tuple. None of this is contiguous in memory, technically. This is the point. It's not even contiguous in memory. Like, it's the wrong name. I'm just going to call this multi then. Problem find. Problem solved. None of this is contiguous in memory. That's kind of the point. So, TB node. So I'm just going to do a slice here. And then this will be the nodes. And that's it. So now every time I have a switch statement on the, like, let's look at the symbol address stuff here. CG value multi, I'm going to call it. We're going to add in the slice. So actually, no, we're going to add in the multiple nodes, multi-nodes and type. We're going to assert that the type is kind equals type tuple. Again, it's a pseudo type. Multi, and then we got multi nodes equals the same thing. And what I'm going to do here is also assert that that doesn't equal null, and nodes count is equal to type tuple variables count. So they must be the same. What I'm trying to say. Yeah? Yeah, this is not the C backend, no. So we're not going for a C backend anytime soon. We're just using the Tilde backend, which is go straight to machine code. So this is what it's going to be. Yeah. So that's what this multi thing is. Next, what we've got to do is we've got to look for every single use in this in a switch statement. So there was a lot of different cases here. And also, oh God, I've also forgot to do the... Close this code. Now you saw what I was doing, but it doesn't matter. CG value stuff. Here, I'm also going to say that this tuple thing has to be greater than 1. Has to be. You can't be anything else. It wouldn't, otherwise it's not multi. Tilde is the backend we're going to be using. This is created by Negate for his quick C compiler. And we're going to be using Tilde because it's great. It's just SSA based. We're going to use it as an alternative to LLVM, and it's being developed as we need. It's the best way of putting it. So yeah, I think this is the way I'm going to design the system. I think I'm happier with this design now, at least. So if I look through here, gbassert value dot kind does not equal cg value multi. Yeah. So there's loads on here. Transmute you should not be able to do. So I'm just looking through all of the switch statement cases. Build expression. So this is where things get a little bit funny. So that should be okay. What about any of the other address things? So let's look in other places. What about in the proc? That's fine. And statement. Okay, so here is the multi. Yeah, so you can't load multiple values at once. This is what I'm trying to say here. You wrote mullet. Did I? I did. I keep saying multi. This is why I was, what? Where? Multi-nodes, multi-nodes, multi-nodes. I don't, oh, that's meant to be a assert. That's why that one's breaking. There it is. So I'm just looking through all of the code here. Oh, oh, that's going to be painful. Let me just check one thing, because I don't think I'll be able to get the address. Oh shit, I'm gonna, it's gonna hurt me when I do this. But I know what I need to do, but I need to, let's just do that, okay? That's gonna be annoying. I don't know how else to deal with that. That's my concern. That should be enough. And then we have the address. So I'm just gonna put here value is not allowed to be a CG value multi. There we go. So yeah, I'm done, I think, tonight. So we were just planning ahead for multi-valued multi-valued values. Multi-valued expressions in the Tilde backend. Commit, push. Hopefully it's working now. Yep. Okay, so I think I'm gonna call that a night. I'm about stuffed, but that's fine. So there we go. I think I'm going to call that a night. So we've been quite productive tonight. Well, I have, not we, but you know what I mean. So thank you very much for everyone for coming in and joining in. If you've got any questions before I go, I'm literally going to get going in like 2 minutes. So ask those questions right now is what I'm going to say. But yeah, it's been pretty nice what we're getting ahead forward with this. So it should be doable is what I'm saying. Yeah. Pretty cool, right? Pretty cool. I might need to, yeah, thank you. Yeah, thank you very much for watching the stream as well. Yeah. Yeah, good night everyone. Okay, so, okay, good night.